1-1 a little bit deeper, just to clarify on stuff, because you guys most of you did not finish your homework. I didn't have it. Okay, so these are the things I know that you should know how to do. If you don't, that's on you and not on me. I did go over them, I think, in depth. 1, how do you find the degree of a polynomial? The highest degree, right? Meaning the highest, not degree, that's the definition of degree. Okay, the highest power, right, would be the degree. Agree? Okay, how do I tell the number of turning points? Not by 2, that's also important, right? It's just not saying if I have x cubed, I can have 2 turning points. That is true, I could have 2, but I also could have 0 as well, right? All understandable. We talked about 2 or 0 if it's x cubed. What if it's x to the 5th? I could have 4, 2 or 0. Right? X to the 4th, I could have 3 or 1. Right? Why could I not have x? Why could I not have 2 turning points on x to the 4th? Let's see if I got it. Oh, I didn't. Here's 2 turning. Oh, there's 2 turning points. Okay. Do we have the same end behavior, Miss Gray? No. No. Why? Needs to be up because of x to the 4th. Semi got you, but you did well. Okay. So once again, if I was x to the 4th, I have to be having that end behavior or that end behavior, correct? Need something of the case. So that's why I always have to have odd degrees of least minimum. Does that make sense? Okay. So we talked about those. We also talked about end behavior, correct? Mm-hmm. How do I justify my end behavior? Well, we look at our degree, don't we? If it's an even degree, remember, as up and up as we go. And then remember, if it's a coefficient that's positive, we have here. If it's negative, we flip it. Right? Everybody with me on that? Remember, if it's an odd degree, it looks like this. As we go to infinity, it increases to infinity. As we go to negative infinity, it goes down to negative infinity, correct? Any questions there? Remember, if it's a negative coefficient, what happens? Flips it. So therefore, let's talk about our end behavior. As x goes to infinity, what's happening here to our y value? Y goes to negative infinity. As x goes to infinity, negative infinity, y goes to positive infinity. We should be able to do the end behavior of every one of those policies. You guys all agree on those things? Did we get to turning points? Not turning points, excuse me. Did we get to differences? We did not get to the chart. Okay. And I know that we didn't get to increasing and decreasing intervals. We're going to start with that. Okay? Increasing and decreasing intervals. This is where we're going to get out our calculator. Okay? We're going to go ahead and get out our calculator. Now, once again, I want to clarify the ones that I will be using in class is the TI-84. Okay? If you have a TI-84 or TI-83, the buttons I push are pretty much going to work for you. Anybody in here have a TI-85 or 86? Or another TI that's not a graphing calculator? So, an 82, that's an old sucker. 81er. It does a lot of the same things except for some things on there that won't work. Just be aware. Anybody have a Casio? Nobody has a Casio. No, you have a Casio. Good. I don't know how to use it. Let me hear you just say, oh, not that Casio. Graphing Casio. So let me just give you a hint. Why do I push a TI-84? I'll tell you why. It's not like I don't think a Casio is a good calculator. The reason why I do it is because the TI actually comes into Utah and pays us to get trained on it. I know how to use it because they trained me on it. Casio says, come in and I'll pay you $100 to learn how to use my calculator. Not one day. That's why in the state of Utah, most of your people use TIs because they come in and pay us how to use them. Hi, guys. With that being said, it kind of makes sense because then what do I come and say? Hey, this is the calculator that I like to use. And what do you guys go do? You guys purchase it. They paid me $100. I bet there's at least 4 of you that bought a calculator this year. They just got $400 for their $100. Does that make sense, though? Kind of give the idea of why we use TIs a lot around here, because they screen it. That lovely calculator is going to work, by the way.
I don't think it's together, but like
Now understand, yes, but there is on this test, I take the calculator away for the problem. So, do you understand how to find the turning points? Remember, look at the degree, go one less, increments of 2. Okay, so once again, if I had x to the 7th, what possibility? 4, 2, there you go. You could have 6, 4, 2, or 0. Now, do I care about the exact amount? No, I'm not. Yeah, all of them, that's the possible turning point. A little later, when we actually graph things, you might be able to see it a little bit. Any questions? Okay, I just want to make sure you guys understand, like, some people have calculated and should I really do the calculator? I'm like, no, it's a great calculator. On some instances, the calculator is better than the TI. But I know how to use the TI. So I don't want you guys to ever feel like I'm pushing product down you. I am in a way, because that's the one I know how to use. But at the same time, other things are just as great. Okay. All right, here we go. So differences. Isn't that what I talked about? We were going to talk about. Okay. So, oh yeah, that's what we're going to start with. Thank you. So I'm going to pull up my calculator. The equation now, really quick, Miss Brown, Bella, Isabella. She has the Wabbit simulator. She has it on her Android. This is awesome. She can use this except for which day? Day. Can't use it on test. Okay? And I was okay with that. Just please understand. Okay. This is kind of your calculator. Just here's the screen. It just makes it bigger. Like if I went ahead and did view. Oh, that ain't it. Hide large display. So that's basically your calculator right there, right? Are you with me? The only reason why I'm doing it the other way, just so you guys get a larger view. And what? Make sense? Okay. So the first thing I'm going to do is y equals. I have stuff in here. I'm going to delete that stuff, so I'm going to hit clear. If you have anything in your y equals, clear it out. Click the clear button. If you do not have a calculator today, I'd highly buddy up with somebody that does, just so you can see what the process and the buttons that you put in. Because guess what? On your test, there's 3 questions you guaranteed need your calculator to actually do. You cannot do them without it. If you're a calculus, you can do them without it. All right. So we're going to do the equation for x. This is our x's right here. 4x, and then I'm going to raise it to the 3rd power. For me, I get put up. If you have a TI-81 or a TI-83, you would not have it up in there. You just have a caret. Okay? Push over. In your guys' case, you don't have to push over because it's not up in there. And then I'm going to do plus 6x squared. So 4x cubed plus 6x squared. That is the equation we have. Does anybody have a question there? Now, just want to stop right here. If I all of a sudden hit graphs and yours doesn't work, it's okay. I will help you after. But I can't go around and help every individual person, or it would take me a long time, and the lessons will go on. We keep it to what we need. Go ahead, if it does not work at a certain point, stop, put it away for a moment, and then go ahead and buddy up with somebody. Make sense? So you can still see what's happening. Okay. I personally want to see the same window as every one of you guys, so we're all the same. So I'm going to hit zoom. And notice the standard button is zoom 6. What that means is it goes from -10 to 10 on my x's. So meaning the lowest number it is -10, the highest number it is 10. The lowest number I have for my y's is -10. The highest numbers I have is 10. That's the zoom standard window. Oh, hot dog. That's not too bad of a graph, right? How many turning points did it have? 2, and could it have 2 as x to the cubed? Is that okay? Yeah. Okay. So with that being said, can you guys see it good enough, or do we need to zoom in? I think it's good enough. My previous one that I used in the last class, we had to zoom in. So I'm just going to show you, just for kicks and giggles, that sometimes the standard window isn't best. So let's just play around just so you guys understand. We can maneuver our window. So I hit window. Let's say it wasn't the best, so I need to go ahead and shrink it a little bit. If you'll notice on my zoom, there is a zoom in. But I don't like to hit zoom in because you don't have control of it. Hi, guys. Right here, but in the blue. Zach, I'll come to you. How about that? Can you put that one in there, bud? Awesome. Can you empty that one? How about this one? You know what, Zach? Can you put it in there? Thank you, bud. All right. So, I'm going to go, let's go -5 to 5. So my x min, remember that's the lowest x value I have. Okay, my y min, I'm going to go -5 to 5. Oops, not that good. And the y scale, what that means is that each increment is being dictated by one tick mark. So I'd go -5, -4, -3. Each tick mark is 1. Everybody with me on that? Do you have a Casio? I can help you a little later. Fair deal. All right. Now, I'm going to go ahead and hit graph just so we can see a better picture. All right. That's a lot better that we can see the graph a little bit better and really investigate it a little bit better. Okay. Got a question for you guys. Because once again, what are we trying to find? The intervals on where it's increasing and decreasing, correct? Okay. So as I'm looking here, as I go from the left, always start at the left. Is my y values going up or are they staying going down? So that's an increasing up until that point right here, huh? In between that point and that point, what's happening? Our y values are going down, so therefore it is decreasing. And from that value all the way over to infinity, it will be also increasing as well. With me? We have 2 increasing intervals and 1 decreasing interval, don't we? Okay, so with that being said, okay, I, Mr. Roberts, am going to find the high point and the low point. So are you. Really quick, I got a question for you. If I'm starting to walk up the stairs, at the very bottom, what am I doing? Am I increasing or decreasing when I'm standing at the bottom of the stairs? Nothing. I'm just here, huh? As I start climbing the stairs and then I get to the top, am I increasing or decreasing? Neither. As soon as I got to the top, I'm no longer increasing anymore, huh? But going up to the top, as soon as I hit the top, I am increasing. Right? So my question I'm basically asking is, at the bottom, at the low of the lows, and the highs of the highs, do I include with brackets or do I not? I do not, right? Because I'm technically not increasing it when I get to the high point or the low point. Make sense? Everybody understand what I'm trying to ask for there? Okay. Let's go ahead. You guys want to find the maximum or the minimum first? Let's do that max right there. Okay, so here we go. I'm going to show you how you do so. Some people are like, oh, Mr. Roberts, use trace it. The trace is a very valuable tool, but it's not the best tool. Okay? It doesn't tell you exactly where that high point is. But if I hit second trace, which is calculate, and you look at that fourth one down, what does it say? Does that make sense to everyone? You could have. I didn't really jump into calculators very much with parabolas, but maybe your teacher did. Okay? I try to teach kids without calculators as much as possible. And some people are like, well, I always will have a calculator. Granted, you might, but still the learning, that's what I care about. Not necessarily always the math part, but math's also part of deeper thinking and learning skills, in my opinion. So I always want to make sure. Now, the first thing this says is left bound. What does that mean? I have to be the left side of that high point. So I'm going to push over. Here we come. All right, right there. I'm good, huh? I'm to the left of the high point. Am I not? I'm going to hit enter. Now, what is it at? Right bound. Now, this is where the Casio comes in. It's really nice. All you have to say is you get your cursor semi-close and hit minimum. And it'll go, whoop, goes right through. So we come over and go to the right of the high point. Hit enter. Now, basically, if you have the TI-84 and you have the color edition, it's giving you these lines. Is your high point in between those two lines? Some of the newer ones. Now, if you have a TI-84 or an 83 that's a little bit older, they still have the little arrows on top. Right? They still have the cool lines to make sure that you're in between them. But is our high point in between those two lines? So we're going to hit enter. The guess, you just basically hit enter. Ba-ba-da-da! What's our high point? -1, 2. Okay, so I'm going to come over here and I'm going to graph my graph a little bit better. Once again, what was the equation that I wrote? 4x cubed plus 6x squared. Is that a correct statement for everybody that may agree? So that was at -1, 2 is my high point. Basically, that's our graph. Not the prettiest, but you get the idea. Okay. Any questions there? Now I want, yes, ma'am. Well, with your calculator, I'll have to help you a little later because it's completely different than what I'm doing right here. So we'll work on that a little bit later. Is that a fair deal? Okay. But just kind of get the idea of what I'm doing here, okay? Just trying to find the high points and the low points. Okay. We'll look at that a little bit later. Okay. So now I'm going to go ahead and, sorry, we went to here, didn't we? Now I'm going to find the low point. So where do I find that low point at? Second, calculate again, except this time I'm going to do what? Find the minimum, which is number 3. Okay, so left bound. Am I to the left of the hump, of the low hump? Yep, so I'm just going to hit enter because I'm already there. Then I'm going to push to the right. Hit enter. Oops. Okay, is my low point in between those two? Hit enter. It's at, this says 5.486 e to the -7 and 1.8 e to the -12, which basically is 0, 0. And the reason why it's not exactly 0, 0, did any of your guys' calculators come up 0, 0? Awesome. And the reason why your guys' didn't, mine didn't, is because your trace increments are different than mine. That's the only reason. But this is basically what? 0, 0. Does that make sense? It does look very closely to that, and I'm not saying it doesn't, but at the same time, we want it to be exact, we want it to. Because what if it crossed, let's say we're doing zeros, what if it looks like it crosses at -1, but it crosses at 0.98, or -0.98? Looks almost that way. Do you want to check it? All right, so we're done with the calculator. You guys understand how I found my highs and my lows? Okay. So this point right here was 0, 0. Let's do our increasing interval. Where is this increasing? Go ahead. To -1. The key thing there, guys, is you use the x values. Even though it's increasing up to 2, what is the interval on where it's increasing? From -2 So 1. Okay? Where else is it increasing from? From 0 to infinity. Now, when there's more than one, you use a union sign. You should have them next to each other, but I kind of ran out of room. Have yours next to each other, though. Okay. Then the other thing we need to talk about is what? Decreasing. Where is this graph decreasing? -1 to 0. Okay? With that being said, you now should be able to answer quite a few extra questions that maybe you had questions on your own. Okay. The other part that we didn't get to was, what else? Say again? The differences. Okay, let me hurry and show you. Notice our goal is to find what type of polynomials they are. Let's start with this guy. Okay? What kind of polynomial would this be? Why is this 4? Always, doesn't matter what your x values were, right? Always 4. We can tell that. Doesn't matter what our x values are, every time it will give me a y value of 4. Okay. This would be a constant graph. Notice because it's constant before I've done anything. Wait, I don't know. Okay, here we go again. Let's do another one. I like to use my Fab 5 of -2 to 2. Goes there. Is it constant? Not right now, it's not, huh? So what we're going to do is what we call our first difference. Okay? How does 6 get to 9? We went up 3. How does 9 get to 12? Oops, not 13. We added 3, right? What happens if our first difference is constant? Do you remember what this is? This is a linear equation, isn't it? Remember, because it has a constant slope. Now, if you'll notice, though, these need to be consecutive numbers. Right? If they're not consecutive numbers, does this work? No. Y equals 3x plus. No. So it would be, oh yeah, 3x plus 12. You're right. Okay. That's no problem. Notice this is linear. What's the degree on a linear equation? 1. What's the degree on a constant equation? 0. Notice right at the beginning, meaning no differences. First difference. If I see a constant on my second difference, what's that going to be? Say quadratic. If it's on my third difference, what is it going to be? Cubic, and so on. Right? Let's just show you the quadratic one more time. That's a 2. Okay, as we can see here, is our constant the same? So it's not the same for our constant. So it's not a constant. You guys all agree with that? Yeah. You're the spirit chair? I didn't know you like your backpack must really, you and him might be really bloody. You're hugging that up. You're hugging that backpack.
Oh,
You ain't
yeah.
getting away. I like to hold pillows when I sleep. My wife's like, why can't you hold me? I'm like, because this is so nice. You asked me to move my arm too much. It's hurting. Will you move your arm? Like, I was fine. Now you're making me move. My pillow never asked me that. Okay, first difference. How does 5 get to 2? We went down 3. How does 2 get to 1? We went down 1. So right now we already know it's not linear. Why? The first difference isn't constant. Huh? How does 1 get to 2? Plus 1. 2 to 5, 3. So it's right there, it's not constant. Let's try our second difference. Our second difference. What happened? Up 2. See how it's constant? Therefore, it is a quadratic. Okay? Does that make sense to everybody? Okay. That right there should allow you to finish your homework. Okay? Notice we went over end behavior. We went over degrees, turning points, increasing, decreasing intervals, and first and second differences. Tenth difference would be of something raised to the 10th power. That means you'd have a heck of a lot of points, wouldn't it? I'm sorry. Okay? Any questions there? Yes. Make a assumption, make a something that you believe will happen. You should have been able to do quite a bit of your homework. So then you should be fine. Why are you worrying? You will have homework every day except test day. I wish I could. I try not to give it because it's the end of the quarter before Christmas break. So what's the purpose of giving you homework over the break? Huh? Most likely not, but most likely maybe for Christmas. Guess what we're gonna have?
It's amazing.
Hi. So what happens to review to me a quadratic, right? We're gonna do 1-2 today, which is actually fairly simple. We've actually had a lot of time that you could actually go in and get extra help via, not via, what the hell am I saying? We're gonna do a lot of things that you're gonna do. 1, how do I add 2 polynomials together? Common, not factors, but common terms. You're going to combine like terms is what we say, right? So if I have 3x squared plus 2 and x plus 7, I just combine like terms, right? We all know how to do that, don't we? And you really do, I guarantee you. How do you subtract polynomials? Distribute the negative through first, right? And then combine like terms. Right? We've been doing that pretty simple. How do I multiply like terms? I mean, polynomials. FOIL is technically what you could do, but that's not technically the definition we're doing. It's called FOILing. Distributing every term into another polynomial, right? So if I had x squared plus 4x plus 7 times x plus 2, I'd take the x squared into the x squared into the 2, right? And distribute it to 4. Make sense? Let me go over that, or you guys okay with that? And then what do you do after that? You combine the terms. Here's the hard one. You guys ready for the hard one? Division. Now it's a little bit harder. Okay, here we go. If I tell you f of x is 3x squared plus 4x minus 7, And I told you g of x is 3x minus 1.
Oh, that's back.
Okay? Will you hurry and go back and just say Mr. Roberts' room? Somebody. Because I just can't fake it back there. You missed it?
Your job.
Can you send it Eliza Johnson to the counseling office?
Yes.
That's true.
Okay, we are going to divide them. Oh, that's a good plus, isn't it? That's what I said it was. I agree. Done.
Perfect, yeah.
Now, we actually can get a little further. We'll talk about that a little later, but not right now. Okay? Okay. Now we're getting into stuff a little bit, really what I want to talk about today, which is even and odd functions. Okay? Mm-hmm. Your choice, Kevin. Okay. Even and odd functions. That's an odd. Even and odd. I will freaking slap you. Okay. Now these might not understand what these mean, but I'm going to show you the definition. If I have a function, f of x, and I take that function and I do f of negative x, what does that mean? What did I just do there? I didn't distribute, but I replaced the x with a negative x, and it comes back to the exact same function we had at the beginning. That is an even function. We'll get to examples in a moment. This kind of is like, there it is actually an even function. Okay, let's, Isabella, explain why x squared would be an even function. So if I take x squared, I replace the x with a negative x. What's negative x squared? Don't I come back at x squared? Do you see how we replaced x with negative x and it came back to the same exact equation? That's true. That's what made it an even function. That's the things that make it, is if you replace an x with a negative x. Now, there's three different types. There's even, odd, or neither. There's an infinite amount of even, there's an infinite amount of odd, and there's an infinite amount of either. Neither. Not either. Neither. Let me see your picture. A little bit. Mine's tomorrow. I gotta pretty up the hair. Getting rid of all of it, meaning. What's that? I do have one that's like this. Okay, it is odd if I replace x with negative x. So notice, guys, by the way, you're doing the same procedure to check if it's even or odd. Okay, you still replace x with negative x. And I'll explain that a little bit different. Right now, you're still like, what the heck is this saying? Okay, that means if it does, and it comes out to be direct opposite, okay, direct opposite of what it was, it will be an odd function. Would be neither. Okay, let's go ahead and show what Isabel already brought up with x squared. Let's start there. Let's go here on this page. Here's our function. Basic. Testing for symmetry.
I know what's going on.
Nice. So math. Okay. So, ladies and gentlemen, how do I test whether it's even or odd? I replace x with negative x. Okay? So what do I do when I have a negative x here? What do I go into this equation and do? Anytime I see an x, I'm going to replace it with negative x. You guys agree that's the same thing that I'm looking for? Because if I wanted you guys to find f of 3, how would you do so? I'd replace the x with a 3, which would have been 9, right? Does that make sense to everyone? Okay. So, question. What is negative x squared? Did it come back to originally what it was? It's the exact same thing. Because it's the exact same thing, that is an even function. Now, some people say, Mr. Roberts, is it any time I have my degree be 2? And the reason is no, it's because of the fact of the matter. Let's go ahead and try this guy. Here's a function. Notice that's still a quadratic, is it not? Is that still a quadratic, though? Okay, so we can't think, oh, any quadratic is going to be an even function. So we have to say, okay, let's replace the x with negative x and see what we get. I get negative x squared minus a minus x. It comes into being x squared plus x. Are they the exact same function? Okay, so no, so it's not even. We know it's not even. Is it odd? Not the exact opposite. Help me name again? Braided. What would be the exact opposite of our function? Nope, negative x squared plus x. To be its direct opposite, which would make it an odd, I'd have to negate the whole function, wouldn't it? Meaning every sign changes. And did that happen? So is this even? No. Is this odd? This is what we would call our neither. This would be a neither function. Okay. Can anybody else think of something that if I replace it with a negative x, it comes back to be the same thing? Another function maybe we've already studied. X to the 4th, yes, that would be great. Anything with an even power by itself, that'd be awesome. Boom. Absolute value. If I had f, ooh. Okay. Now necessarily, that wasn't my fault. Replace the x with negative x. What's the absolute value of negative x? It's still equivalent to being just, we could call that just absolute value of x. It's the same idea, right? Kind of like absolute value of 4, absolute value of negative 4, still 4, right? In the end, they have the same distances, correct? I want to get a little harder and just ask you a question. So is this even or odd? Even, because it comes back exactly what we had, right? Okay. Do you guys see something? I know I don't want you to bring it up because you already mentioned it. But talk about an x squared graph, which looks like this. Okay, absolute value graph, which looks like this. And then we had, was it x squared plus x or x squared minus? It was minus. So then we had this graph. Those are the graphs of the things that became even and the one that did not become odd. I mean, didn't become an even or an odd. It was neither. Not necessarily. Can anybody tell me what they see common between the two blue ones? The turning points are on the y-axis. Back? No, not necessarily. Okay. Not necessarily one turning point. Here's another one. Not congruent. There we go. Imagine that was perfect, right? I'm not an artist, but get the idea. They all, if they are an even function, they are symmetrical about the y-axis. What does that mean? Means if I folded on the y-axis and I put them right on top of each other, like basically let's say our palms, unless you got went to the wood shop and cut one off. Basically your hands are symmetrical, aren't they? If you folded them right on top of each other, right? Unless you have one of those club thumbs. Anybody have a club thumb? I always say that. My buddy, he's got this one thumb, it's normal, and then he's got this sucker that looks like a big toe got sewed on. Okay? That's a I actually know like 10 people that have a club thumb. Do we have one? Looks like a big toe, freaking big toe. It's okay, I'm not mocking you, just a little bit, but they look really like everything else the same, and then they got this big old freaking club on this side, and then they got a normal side. Robert's son. Okay. So, really quickly, since we're talking about symmetry, what kind of symmetry does an odd function have? Odd function, go ahead, Isabel, you can just say it. Which is called the origin. Symmetric. And I'll explain what that means about the origin, because I used to always get confused about that. Here is x cubed. Did we already prove that x cubed was an odd, right? Did we prove that or just talk about it? Oh, we didn't. Oh, well, I just told you one. Let me just show you. F of x is x cubed. Let's prove that it is odd. I'm going to replace the x with who? Negative x. If I have negative x times negative x times negative x, I get negative x cubed. Is it its direct opposite? Yes. What does opposite mean? Just negating the power. Not the power, negating the terminal. I meant the terminal and the term. You got me all frustrated. The term. So it's just negative x cubed. Here's what we got. If I plugged in and graphed x cubed, 0, 0, 1, 1, 2, 8, negative 1, 1, negative 1, 2, negative 8, which is down here, which I'm not going to be able to get, but negative 2, negative 8 is also 1, right? I went through every dot, didn't I? Okay.
Yeah.
So, notice here though, look at the points. 1, 1 was 1, as was who else? Negative 1, negative 1. Look what we just did. If I replace the x with its opposite, did I get the y's opposite? Yeah. What was another solution we had? 2, 8. Who was another one that didn't get on the board then? Replace the x with its opposite. Did I get its opposite? That proves that it's an odd. Okay. So, symmetry about the origin is technically what that means. Is you take this coordinate, this quadrant, and you flip it down, and then flip it over. Does that make sense? Or if you reflect about the y-axis and then reflect about the x-axis, excuse me, reflect about the x-axis and then reflect about the y-axis, would you get the exact same graph? Yeah. Does that make sense what I'm saying? Want me to show you what I mean by that? So here's that x cubed. Let's reflect about the x-axis first. So reflecting about the x-axis would make it look like this. This stuff flipped up here, this stuff flipped back down. Right? Okay. Now we're going to reflect the blue over the y-axis. So where's this stuff going to go? Right on top of the red, and this blue is going to go right on top of the red. Do you see how I've reflected over the y and the x, and it came back to be the exact same graph? That is a reflection about the order. Okay? Now, on your test, there's going to be a time that I'm asking you to look at the graph and tell me whether it is even or odd or even. But I don't want you to do everything by looking at the graph. I want you to also go ahead and do an algebra, which is by replacing the x with negative x. I'd like to talk a little bit and ask you a question. Is this, oops, I don't know why I did a number sign. Hey, not a hashtag, you use pound. I don't know what the hell you're talking about. It's music, and I freaking failed the recorder in 4th grade, and I said, you know what, music? Screw you. I did. Recorder, I failed it. Straight up. I was playing me some hot cross buns, like such. Did you notice I whistled? Because I did in my test, too. I whistled, even though I had it right up to my lips. She's like, that sounds so beautiful. I'm like, you know. And then she's like, your fingers didn't move. And I said, screw it. And I threw it down to the ground. And I said, no more. My daughters are playing piano. I'm like, why am I wasting my money? Are you going to be Mozart? No. It's a reflection about, it's symmetry about the origin. It means it's off. Thank you. Okay, are those equal to each other? I just take the absolute value of negative x and it becomes x and I'm happy day. No. Now, x plus 1 is equal to y. No, they don't. It's not because they're both negative. Well, in a way, I guess. But I can actually factor out a negative. Oops. This is kind of a thinking skill. This and this are equivalent, correct? You guys agree with that? How I factor out a negative, if I distributed it through, it'd come back to him, would it not? Okay? Do you guys see how this guy, this absolute value is equal to this absolute value? Why are they the same? Let me, give me any number. Okay, in a way, yep. Give me any number. 6. Okay? What's equivalent in absolute value to absolute value of 6? Absolute value of -6. Imagine this x plus 1 as 6. Isn't this x plus 1 here 6 as well? But with that minus out there? So don't I have absolute value of 6 and absolute value of -6? You see how they're the same? Because I was able to pull out a negative, and this distance is the same as this distance away from 0. You see that? Because remember, absolute value means a distance away from 0, right? Let's plug 6 in here. What's 6 plus 1? 7. 6 plus 1? 7 with a negative out here. -7. Absolute value of 7 and absolute value of -7, are they the same? Let's do 6. 6 plus 1? -6 plus 1? -5. No. So that's a key thing, guys. Make sure that a lot of people struggle with absolute value. So who is equivalent to this guy? -x minus 2, right? For the fact of the matter, I could pull out the negative. And once again, negative distance. That distance and this distance are the same away, right? Does that make sense to everybody? Just because this is absolute value, does this make it an even function? No, because how many of you guys remember what absolute value graph looks like? It's a V, right? What does the plus 2 on the inside of the absolute value do to my graph? 1, 2. Am I symmetrical about the y-axis anymore? I'm not. I'm a function, but I'm not even or odd. I'm just a zero. Neither and either. How are we doing? You guys want 20 minutes of homework here? Yeah. That's where we're at. So,